In this video, we're going to take a look at something called a logarithmic function, and it's another way to express an exponent. So if y equals b to the power of x is the exponential form of an equation or a function, then x is equal to log base by is called the logarithmic form. So how do we convert between the two? So notice where the base is b, x is the exponent, and y is equal to the value when you take b to the x. Notice the answer to a logarithm, x is the power, is equal to the log base b of y, which is the answer. So a logarithm is an exponent. Okay? Exponential answer to an exponential is what you get when you take base to the power, and answer to a logarithm is the power. So let's take a look at some examples. So you can rewrite any exponential expression as a logarithm. So here we have 3 to the power of 2 is equal to 9. So writing that in logarithm form, log base, the base is 3. The answer is 9. Log base 3 of 9 is equal to 2. So the answer to a logarithm is the exponent. Let's try that on another one. Next one we have log base, the base in this case is 32, of 8, which is the answer to the 32 to the 3/5 equals 8. Log base 32 of 8 is equal to the power. Okay, so a logarithm form and exponential form, these two mean the same thing, but they're written in very different ways. We can also go backwards, or the other direction. If we have a logarithm, we can rewrite it as an exponential. So the first log base 6 of 1 over 36 equals negative 2 means the base is 6, the power is negative 2, is equal to 1 over 36. So exponential form, 6 to the power of negative 2 equals 1/36. Logarithm form, log base 6 of 1/36 equals negative 2. Next, notice we have a number in the front. We have a 4. And in our property up here, there is no number. So what we have to do first to both sides is divide both sides by 4 so that we're written in the correct form. Log base 16 of 8 is equal to 3/4. Now we can convert that to a power. So our base is 16 to the power of 3/4 is equal to 8. So it'll take a little practice to get used to it, but a logarithm is another way to write an exponential expression where the answer is the power. So how do we use this? So a couple of examples we're going to look at. We're going to evaluate a logarithm by changing form. On our first example, we want to find b, given that negative 4 equals log base b of 1 over 81. So we've got to convert that. Let's convert it to an exponential equation and see if that makes more sense in exponential form. So b to the power of negative 4 is equal to 1 over 81. Okay, so we're trying to figure out what value of b taken to a power of negative 4 gives us 1 over 81. So if you remember, negative powers are fractions. That's 1 over b to the 4th is equal to 1 over 81. So we want to know what number multiplied by itself 4 times is equal to 81. So 2 is too small. The next, it's got to be a small number. So try 3. And 3 times 3 is 9 times 9, which is 81. So b is equal to 3. Next, given log base 4 of y is equal to 1/2, we want to find y. And again, it will help to put this in exponential form. 4 to some power 1/2 is equal to y. So we have 4 to the power of 1/2. So you can use your calculator for this. Or if you remember from sometime, somewhere, someplace, that if you have a power, a fraction power, anything to the power a to a fractional power n divided by m is the mth root of a to the n. So this means this is the square root of 4 to the power of 1. And the square root of 4, which we usually don't write the second root, the square root of 4 is equal to 2. All right, so now that we've taken a look at the definition of a logarithm is another way to write an exponent, now we're going to take a look at the logarithmic function. So we're going to take a look at the graph of y is equal to log base 2 of x. So I'm going to rewrite that as a power, just so we can take a look and plot some points. Written as a power, that says that 2 to the power of y, let's see, let me get in the right spot here. 2 to the power of y is equal to x. I don't know why that keeps disappearing. Let me try that again. Technical difficulties on the pin. All right, I'll try it down here. 2 to the power of y, there we go, is equal to x. I don't know why that's disappearing. There it is. All right, 2 to the power of y equals x. So notice that's opposite of what we graphed before. We graphed y is equal to 2 to the power of x. So I've put the values in for y this time, because we can take 2 to that power. So notice the x and y's are switched in the logarithm when they were exactly opposite of what they were in the exponential. So when we substitute -3 in for x, we get 1/8. -2, we get 1/4. -1, we get 1/2. 0, we get 1. 2 to the 1 is 2, 4, and 8. So when we graph these, we end up with the x and y coordinates switching. So the basic features are the domain is x is greater than 0, because we can only have positive values for x. The y-axis is an asymptote this time. Before, it was the x-axis that was the asymptote. And if x is between 0 and 1, log base b of x is negative, less than 0. If x equals 1, the log of base b of x is 0. If x is greater than 1, log base b is greater than 0. So basically what that says is it's increasing function from left to right. But you can't put values 0 or values less than 0 in the function. Okay, so the relationship between the logarithmic and the exponential is they're called inverses of each other. So I just wanted to put this on the notes so you could take a look. When we graph the functions 2 to the x and log base 2 of x, one of them increasing, the other one is increasing, but the x and y coordinates basically are switched, then this is the relationship that they have. They're called inverses of each other. And that means the domains switch, the x and y coordinates switch, the range, domain and range of one, or the range and domain of the other. So that's what the graphs look like. Sorry, my pen started to not